Hey folks, today I will discuss about the C++ memory allocation. This is one of the major concept of C++. In my previous vlog, I talked about these stack allocations with C++, and I promised that I will discuss more about the memory allocation with Heap. So please share, subscribe and like my channel. So let's start today with the heap and stack based memory allocations and how they are different. So for stack based memory allocations, we need to know about the heap allocations, and for knowing that, we need to have some idea about the stack allocation itself. So in stack allocations, what happens is that when the allocation goes out of scope, it just removes all the memory associated with the object itself. So if my class is my class and my object is the object of the class, and if I create a function which has a scope of open brace and close brace, whenever it goes out of scope, that my object gets deleted. Even if we can create any scope, maybe we create another scope inside this function, and if I do that, then when it goes out of scope, my object is deleted in this within this function but outside this curly brace itself. So this is the stack allocations. So now the advantage of stack allocation is that we do not need to think of explicit delete of the object or explicit removal of the object, because we are ensured that whenever it goes out of scope, it will be automatically deleted from the memory. This is the advantage. Uh, when we talk about the heap allocations is basically the ownership of the object. Now ownership of the object, it does not go out of scope. Even if it goes out of scope, the object is being allocated throughout the program until and unless a particular function takes the ownership to delete the object explicitly. This is the difference between the stack allocations and the heap allocations. And so in heap allocations, we have two major concept, that is a new and delete. What is new and what is delete? Let me first write the basic syntax of new. If I have a my class, so I will prepare that a new keyword before that my class. That will create an object, and how to hold that object? With the help of a pointer. The pointer should be of my class itself. My class start p. This is called new, and we need to explicitly delete this my class object pointed by the pointer p by explicitly calling the delete p. The basic syntax of new and delete are like this. Now particularly for C programmer, or whoever has been transitioned from C to C++, there is a concept of malloc and free also. Now what is malloc and free, and how this new and delete is different from malloc and free, and what are the advantage and disadvantage of new and delete with respect to malloc and free? It's mostly the advantages that I will talk about this. Now what happens in malloc and free? The syntax of malloc is basically like this. Whenever we do a malloc, we do a size of operator and we write the class name. So that means that it will allocate the object, it will allocate the memory for the class object, but it returns a void pointer. So this creation of the void pointer can lead to a disaster in C, because in C void pointer can be converted to any pointers. So this is one advantage of new with respect to malloc. Another advantage is basically the flexibility. What happens with new? The flexibility is we can overload the new so that we can do our memory allocations ourselves. So the two things, um, new delete, which is basically C++ stuff, and malloc free, which is C stub, and first one is basically it is new and delete. New, rather new is type safe. That means it returns, it does not return any void pointer, but it returns a pointer of the class itself. And the second thing is that flexibility. Flexibility, basically overloading is possible with new. So these two are important things to remember here. This is basically the transitioning from C to C++ in terms of memory allocations for a data type. So we need to know something more about this new and delete. Now, what is new? What does the new do? New does two things. One is basically it allocates enough memory to store class object. Secondly, it calls constructor. Constructor is something that I described in my previous vlogs. It calls constructor means that it initializes the class data members with the help of this constructor. So two things, first of all, memory allocations and initialize. Initialize. This is the responsibility of new. And delete does the thing in opposite way. What delete does is basically reset values which has been initialized during the construction and release the memory by deleting the class object. So this is the summary of the new and delete operations. So we know about the memory allocations, we know about heap and stack allocations, we know about new delete now, and it's in comparison to malloc and free. Now, one another important things to know is that whenever we declared some heap allocations, creation of some class object, do we need to check that if it is not null? Do we need to check that? The answer is that no. This is a bad form. New guarantees that it will always return a non-null memory. Even if there is some shortage of memory, it will throw an exceptions. This will only hold true if you write some no throw after new. That means that you are telling the compiler, do not throw any exceptions. Let me handle in my program itself. Then this is okay. If we write a no throw here, this is just for knowing this stuff itself. Another thing is that during the delete operations, do we need to check the pointer again? If P then delete, this is also a bad form of programming. It is not required because even if P is null or 0, it is fine. Delete operation, it handles itself. So these two are um, the better programming approach with new and delete. Now, if we need to create a multiple, if we need to create multiple objects, what we'll do? We do a array of object. That means we can write it this way. Maybe 50 objects we need to create. We'll do a new and we'll write like this. Now, how we will delete these 50 objects? Do we write only delete operations? We need to do a additional brace itself. Just letting the compiler know this is the array object to be deleted. Now, one important concept here, how compiler knows at this point how many objects to delete. The important thing is that whenever you write an array of object allocations here in the memory, at the initial position, compiler creates a map kind of things where it stores the pointer versus the sized stuff. So whenever we write a delete here, compiler directly does a lookup with the pointer and find that what is the size. If it is a 50, then it removes these 50 objects from the memory. This is another concept that is interesting for C++, the array of object allocations and delete. Another interesting thing is that what is called placement new. Placement new is a special type of new operations. We write a syntax first here. We write a pointer p. After this new operations, we write my class. And so what is p? So p is basically something, a predefined or pre-allocated memory. If we know some particular hardware memory allocations, maybe something like 0xFF, something something, so we can directly use that after new. There is another application is that in professional programming, what happens is that there is a chunk of memory which is allocated at the beginning of the program and is being managed by the memory manager. Now, when user does a coding of particular applications, he takes the memory from here with the help of this placement new. This is an applications. Now, another thing just to mention here with the help with respect to placement new, that we need to explicitly delete the memory created by the placement new. How? We need to call the destructor like this. This is the destructor which is being called explicitly for this pointer for placement new. And this is the only place where in C++ we need to require the explicit call of the destructor. This is also something to be remembered with respect to placement name. Another small things that maybe can be mentioned here. If the memory allocations and deallocations is very frequent in terms of performance, instead of doing a delete operations, discard is another options to do. P discard. If you write a discard operations here, what it does, it instead of deleting this memory or object, it puts this in the static pool of memory, so that later on when a further new allocation is being done, it pulls out this memory storage from there instead of allocating a new memory. And with respect to P discard, we need to do a create operations also like this. So discard and create. If it does not find any static memory pool, so it does a straightforward memory allocations. No static pool, then it does normal mem allocations. This is also small things but good to know. Another thing is that concept of operator new. What is operator new? What it does when you call a new my class, what happens? When we call a new operations here, the compiler is basically call a function called operator new. This is the operator new stuff, and the signature looks like this. It returns a void pointer. And similarly to the new, if we write some delete operations, it does a operator delete call. Memory allocated to free the memory. This is operator new and operator delete. Now as a programmer, this operator new and operator delete in the program can be overloaded, and instead of allowing the compiler to do a memory allocations, this can be done by the programmer itself. He can easily write a operator new overloading function himself and does a memory allocations, and then call the constructor. What basically the new does. And last but not the least to be discussed here with respect to memory allocations with new and delete is basically, if we have a stack allocation, if we have a heap allocations, it is a programmer's practice that which one should be used, stack allocations or heap allocations. Generally stack allocation is preferred, but in some cases when object ownership is important, the heap allocations is being preferred by the programmer. In that case, if we need to protect the programming of stack allocations, if we need to ensure that all the allocations of a class will be a heap allocations and no stack allocations, maybe we can ensure that by writing some class like this. We can encapsulate this all the constructor in private area, to write something like my class, all the constructor, maybe my class, then int, my class, maybe float something, all the constructor. You are protecting this constructor like this, so that user cannot allocate from the stack. Instead of that, in the public area you write some create function, and the create function is basically defined like this. So call the create functions and it will do a new operation inside this. My class pointer, and you return this pointer in your main function. So it will be basically my class pointer. So in your main, when you actually call, this is a static function. When we call my class create, it will return you a my class object pointer. This way will ensure that all the object creation is being done in the heap. So I think this is enough for today. All the topics that I have listed here, I tried to explain it part of this presentations. I hope you like it. So if you like it, please share and subscribe my channels, and also like it. Thank you very much.